This related rate problem is about sailing. Two boats living at the same location at 6 a.m., one sailing south at 13 miles per hour and the other one sailing east at 16 miles per hour. How fast? How fast means the rate of change. That means slope, that means derivative. Is the distance between the two boats changing at 10 a.m., so that will be 4 hours later. Okay, so the first thing when it comes to related rate problem, you have to draw a picture. So let's write this down. So the first thing is you have to draw a picture. So we have a picture, and then we have the west, the east, the north, and south. So the first boat is going south at 13 miles per hour. So let's call this a y. Okay, so let's call this a y, and then label this y, and then do we know the dy dt? So the dy dt is 13 miles per hour. So dy dt is 13 miles per hour. So that is given in the first sentence, right? Going south at 13 miles per hour, and then the other one is going east at 16 miles per hour. So let's call that x, and then dx dt is 16 miles per hour. Okay, what are they asking? They are asking for the rate of change, the distance between the two boats changing at 10 a.m. So they are asking for this. Suppose that is the distance d, and then they are asking for dt. So dt, what is that equal to? 4 hours later. All right, so what is the equation? So we have to draw an equation, one equation to describe the entire situation. Do you still remember this? So every time you solve an application problem in math that requires setting up an equation, you have to write one equation that describes the entire situation. So since this is a triangle, I will be using the Pythagorean theorem. Right, so let me write this down. So we will be using the Pythagorean theorem. And this works for right triangle only. Right triangle means a 90-degree triangle. So the Pythagorean theorem is x squared plus y squared, that is equals to d squared. Okay, so this is our equation. So what we have done so far is we need a graph, and then we need labels, and then we need an equation. And then the next step is derivative using implicit differentiation. So that is respect to what variable? So this is with respect to time. So take the derivative on both sides with respect to time using implicit differentiation. So power rule, so we have dx, so with respect to time means we have to add a dx dt to it, and then 2y implicit dy dt, and then we have a 2d, and then dd dt. Okay, so the implicit differentiation is done, and then the next step is you have to do a plug-in. And then you solve for the unknown. All right, so what do we know and what do we don't know? So we have dx dt, we have dy dt, but we do not have x, and we do not have y, and we do not have d. So how do we figure out the x, y, and d? So to figure out the x, y, and d, you have to do one more equation. So what is the relationship between x, y, and d? So the relationship is, so let's draw this triangle again. So we have a right triangle, and then this is y, this is x, and then this is d. Okay, what is x equals to? Do we need the Pythagorean theorem to figure out x? No, we don't need that, right? So because since we start at 6 a.m. and then we stop at 10 a.m., so the time is equals to 4 hours, right? So we have the speed. The speed is 16 and 13. So for x, that is 16 miles per hour, and then you travel for 4 hours, right? So the distance is equals to 64 miles. And then for y, the speed is 13 miles per hour, and then the ship travels for 4 hours. So 13 times 4, that is equals to 52. So x is equals to 64, and then y is equals to 52. So now we can just solve for d using Pythagorean theorem. We have 64 square plus 52 square, that is equals to d square. All right, so this is 6800, equals to d squared, and then when you take the square root of that, so the square root of 6800, so this is approximately equal to, I will just round this up to 1 decimal place, which is 82.5 mile. All right, so now we have xyd. So the only thing, what do we don't know? We do not know dt, right? So this one, we do not know. Okay, let's plug in everything we know, and then we solve for the thing that we don't know. All right, let's perform the plug-in. So we have 2, and then x, what was x? X is equals to 64 miles, so 64. And then dx dt, that is 16 miles per hour. And then 2, y is equals to 52. And then dy dt is equals to 13 miles per hour. And then equals to 2 times the distance d, which is 82.5. And then we don't know d dt, right? So d dt. Okay, let's just erase this because everyone knows that it solves. And then d dt. All right. So on the left hand side, you multiply and then you add, that is equals to 3400, equals to 165, and then dt, 165 dt, and then you take the 3400 divided by the 165, so dt, that is equals to 3400 divided by 165. So that is approximately equals to 2.60, or you can write 2.61. So the number of decimal places you have to, read the problem and and find out how many digits do they want. So 20.61 miles per hour. So one going to the south and one going to the east. At 4 hours later, we can find out that the distance between these two boats is changing at 20.61 miles per hour. Let me ask you an additional question. Can the dt be negative? The answer is yes. So this is positive because the distance, do you see the d in the triangle? Do you see this d? Do you see that? So dt is positive. That means the distance between them is increasing at that time. So 4 hours later, at that time, the distance between those two boats is increasing. And then what if that is negative 20? If that is a negative 20, that means the distance between those two boats are decreasing. Okay, so that is the end of this problem. If you think my instruction is clear and helpful, give me a like, share the video for me, click the subscribe button if you are new to the channel. I will see you all in the next related problem. Signing out.